of all, let's go and have a look at our function. Here it is. Or not, because my pen's not working now. What could possibly go wrong? Oh, we're back on. Okay. No, we're not. Yes, we are. Okay, here's my function. So we type that into the calculator. We get the TI-Nspire ready to go. Here it is. And I've got it here, 1,806 multiplied by 1.037 to the power of, it says t in the question, but we make it x, because x as the input. When we press enter, of course, we can't see anything, because the graph is somewhere on there, but we don't have the correct scale. Here is your magic button. Ready? Control T, which makes the table of values. Now, when you're over here, look, this is t equals 0. This represents 1960. In 1960, this is how many US dollars or whatever unit we're measuring in. This is 1961, 1962, 1963, right? So you can see that the x numbers, we should really start at 0, and then maybe go up to 50 or 60 or 70. And then the y numbers, obviously, look, we need to get up to, I don't know, 2,000s, maybe 3,000s, 4,000s, 5,000s, okay? So the table of values is really helpful because it gives us an idea of the scale. But even better, if I actually go back to the questions, question A says write down in US dollars, because this is how it's measured, the GDP per capita in 1960, that's part A, and the Australian GDP per capita in 1961. We already have those two answers. Look, when we get to our TI-Nspire, this is how much in 1960, this is how much in 1961. We already have the answers. Yeah. So the table of values is really, really useful, really useful. But I will show you how to do those two answers in a slightly different way. So Control T to turn the table of values off. Control T to turn it on again. So let me get rid of it. And now I want to change the scale so I can see the graph. Menu, Window Zoom, Window Settings. The X, I'm going to go from -1 year, and I'm going to go up to maybe 50 years. And the Y, I need to go up to maybe 5,000. And here I have the graph already, okay? So you can see it's obviously growing really well. Those of you who know this function here says that 1.037 is actually a 3.7% growth per year. This is compound interest. This is compound growth. All right, let me go doc. Let me insert a calculator page. Now, this function is called F1. Watch the magic. If I type in F1, can you see how it goes bold? And if I type in 0, we've seen the answer before, right? This is, what is the function worth at time value 0? And let's do F1 of 1. So the answer on the right-hand side is literally the GDP per capita at time period 1. So we could just keep doing this. F1 of 10, after 10 years, this is the GDP per capita. And remember, 10 years after 1960, this is 1970. Shout out, what do I type in for the year 2000? What goes in here for the year 2000?
20.
Not 20.
15,
40. Right, because the number is how many years after 1960. So already you can see that in 40 years, we've grown from 1,806 all the way to 7,724, right? It's amazing. This is what compound growth does for you. So let's go and answer the questions. We've answered question 1A was how much in 1960. We've got that answer already. It's there, 1806. Part B, find in 1961. Well, we've got that answer because that was 1 year later. Then part C is working backwards. So we need an answer of 100,000 and we need to guess the year. So basically we've got to keep guessing here. So we get 100,000 coming out here. So you can see that you can guess pretty efficiently. This is 141,000, it's too much. But there's a better way of doing it. And now, menu, algebra, numerical solve. I think you guys remember this. We're going to solve f1 of x equals 100,000. And we type in f1 of x here because that's the equation that we had before. But we have to solve it, comma, x, boom. 110.5 years after 1960. So the actual year is 1960 plus 110.48. In the year 2070, it's predicted that the GDP per capita will get to about 100,000. You're welcome. Remember to subscribe, hit the thumbs up, and like.